So if the integrand approaches infinity at one or both points of the limit, ano daw? And then since nag-substitute tayo, and then since nag-substitute, and Hello everyone, it's me again, Ma'am Ima, and this is the last Math 100 lecture video that you have to watch. So for today's video, we are gonna talk about improper integrals. So for the past lessons natin sa integration, you've learned na you can think of the definite integral as the area under the curve. Kaso, paano natin siya approach if, halimbawa, at some point of the curve, may discontinuity, pero you still want to get the area under that part. Or halimbawa, may asymptote. Technically, may area pa rin sa ilalim ng curve na yun, pero di ba, pag ganun siya, whoosh. Wait, what? Because in defining the definite integral, we have the following assumptions. That the closed interval from a to b is finite, and that f is bounded and continuous on the interval a to b. So, ang titingnan natin today is how to solve definite integrals kung isa dito sa mga assumptions na to ay hindi nasusunod. In other words, one or both of the limits of integration are infinite, or meron kang infinite discontinuity on the interval where you want to integrate. So, integrals that have one or more of the characteristics we just mentioned, ang tawag natin sa kanila ay improper integral. So, to visualize a bit better yung gagawin natin today, let's consider this function y equals e to the negative x. So, kapag graph natin yan, ito yung tsura niya, may asymptote siya sa y equals 0, diba? So, what if we consider the region bounded by that curve, the x-axis, the y-axis, and a line x equals b, where b is some positive real number. So, pag graph, ito yung tsura ng region. So when we compute for the area of that region, we have the integral from 0 to b ng e to the negative x dx. And then that is just equal to negative e to the negative x evaluated from 0 to b. And then we have minus e to the minus b minus e to the 0. So that's just 1 minus e to the negative b. So ngayon, papalakihin natin yung value ni b without bound. So hence, when we take the limit as b goes to positive infinity nung kaninang integral, so palitan lang natin nung nakuha nating sagot. We have the limit as b approaches positive infinity ng 1 minus e to the negative b. Ang e to the negative b, saan to pupunta as b goes to positive infinity? This goes to 0. So ang natitira lang ay 1. So this limit will be equal to 1. So that means, kahit gaano natin palakihin yung value ni b, kahit goes to infinity yan at kahit may asymptote yan, yung value ng area sa ilalim ng curve will never exceed 1 square unit. So ganitong klaseng integrals yung titingnan natin today. After taking the limit, the way we interpret it is, if the limit exists as some finite number, basta hindi siya positive or negative infinity, we say that the improper integral is convergent. Otherwise, if the limit doesn't exist, it is divergent. So, ang una nating titingnan na klase ng improper integral ay kapag isa or both limits of integration are not finite. So first, if f is continuous for all x greater than or equal to a, then the integral of f from a to positive infinity will be equal to the integral of f from a to some variable b. And then you take the limit of that as b approaches infinity. So ito yung parang yung ginawa nating example kanina. Next, if f is continuous for all x less than or equal to b, then the integral of f from negative infinity to b is the integral of f from some variable a to b, and then you just take the limit of that integral as a approaches negative infinity. So, imbis na yung kaninang upper limit yung papalitan nyo, yung lower limit yung papalitan nyo ng variable. And then lastly, if f is continuous for all values of x and c is any real number, then yung integral ng f over negative infinity to positive infinity, ang gagawin nyo muna is hahatiin nyo yung integral. So, gagawin nyo siyang integral ng f from negative infinity to any real number c plus yung integral ng c to positive infinity ng f. Tapos, apply number 1 and number 2 to each of the integrals. So, you get the limit of the integral of f from a to c as a approaches negative infinity plus the limit of the integral of f from c to b as b approaches positive infinity. So note that if at least one of the improper integrals on the right-hand side is divergent, so kahit isa lang dyan makuha kayo ng positive or negative infinity sa limit, then automatically yung improper integral sa left-hand side ay magiging divergent na rin. So first, let's have this example. Evaluate the integral from 0 to positive infinity of x e to the x squared dx. So ang integral natin, x e to the x squared is continuous for all values of x, no? So ang problem natin dito is yung positive infinity sa limits of integration. So i-rewrite natin tong integral na to as, ang papalitan niya ng variable yung may positive infinity. So you can choose any variable you want. Kunwari, sige, t. We will write this as the limit of the integral from 0 to t of x e to the x squared dx as t approaches positive infinity. And then you just evaluate the definite integral as usual. So we first evaluate yung integral from 0 to t x e to the x squared dx. And we will just use substitution for this. So we let u be x squared. So du is 2x dx. And then, at this point, kayo bahala kung paano kayo most comfortable magsagot ng definite integral questions. Pwedeng unahin nyo muna yung indefinite integral and then evaluate, or pwedeng dire-diretso nyo na to the definite integral, tapos palitan nyo na lang yung bounds. So we're writing everything in terms of u. You have the integral of 1/2 e to the u du. And that will just be 1/2 e to the u plus some constant c. And then ibabalik nyo lang yung sinubstitute nyo. So you have 1/2 e to the x squared plus c. So you have the integral from 0 to t ng x e to the x squared dx should be equal to 1/2 e to the x squared evaluated from 0 to t, which is equal to 1/2 times quantity e to the t squared minus 1. So, same lang yung makukuha nyo kapag dinire-diretso nyo na yung sa definite integral with the bounds. So, pag pinalitan nyo yung bounds, so at x equals 0, u should be 0, and when x equals t, u should be t squared. So, magiging siyang integral from 0 to t squared ng 1/2 e to the u du. So, dapat pareho lang yung makuha nyo yung final answer. So, again, note na hindi pa tayo tapos. So, now we have to compute for the limit. So, we have that the integral from 0 to positive infinity ng x e to the x squared dx will be equal to, so ginawa natin siyang limit as t approaches positive infinity nung kaninang integral. And dahil alam na natin yon, we now have the limit as t approaches positive infinity of 1/2 e to the t squared minus 1. And yung constant, wala namang mangyayari dyan, so iwan lang natin siya. Ang talagang kailangan nating tingnan is yung part na may e to the t squared. And where does e to the t squared go as t goes to positive infinity? It also goes to positive infinity. So, yung isang term pupunta ng positive infinity, and then you have a constant. That whole thing will still be going to positive infinity. So, this whole limit goes to positive infinity. At dahil hindi real number yung limit, we say na the integral from 0 to positive infinity of x e to the x squared dx is divergent. So for our next example, let's evaluate this integral. The integral from negative infinity to 0 ng 1 over x squared minus 2x plus 1 dx. Okay. So check natin yung integrand. Note na yung 1 over x squared minus 2x plus 1. Yung denominator, we can factor that as x minus 1 quantity squared. This is, meron siyang discontinuity sa 1, pero wala naman yun sa interval of integration natin. So, continuous siya actually dun sa negative infinity to 0. So, ang gagawin natin is similar dun sa ginawa natin sa una. Papalitan naman natin ngayon yung limit of integration na nasa baba. So, now we have the integral from negative infinity to 0 ng dx over x minus 1 quantity squared. So, gagawin natin siyang limit ng anong magandang variable, sige, star. So, limit as star approaches negative infinity ng integral from star to 0 ng dx over x minus 1 quantity squared. And to integrate this, you can just do substitution and then power rule, no? Which will give you the limit as star approaches negative infinity of negative 1 over x minus 1 evaluated from star to 0. And that will just be the limit as star approaches negative infinity ng quantity 1 plus 1 over star minus 1. And again, yung constant, wala namang mangyayari dyan. So, kung titingnan natin yung term na 1 over star minus 1. So, yung denominator is linear, tas approaches negative infinity. So, yung buong denominator just goes to negative infinity. But then you have 1 over something na pupunta sa negative infinity, the whole term will go to 0. So, you're just left with yung constant kanina, which is 1. So, therefore, yung integral from negative infinity to 0 ng dx over x squared minus 2x plus 1, we say that this is convergent kasi the limit exists. Okay? So, yun lang naman yun. So, for our next example, let's evaluate the integral of x squared dx from negative infinity to positive infinity. So, again, kapag both limits of integration ay may infinity, kailangan nyo muna siyang hatiin on any real number. So, pwede rin siya nating hatiin anywhere on R. So, for ease, let's make hati. Let's make hati! Hatiin natin siya sa 0. So, write nyo siya as the sum of two integrals. You have the integral from negative infinity to 0 ng x squared dx plus the integral from 0 to positive infinity ng x squared dx. Alright? And then, both of these, i-rewrite nyo as limits. So, you have limit ng, say, sige, a approaching negative infinity of the integral from a to 0 ng x squared dx plus limit as b goes to positive infinity ng integral ng x squared dx from 0 to b. Okay? And then, you can just use power rule to integrate. These are both x cubed over 3 lang, no? So, you first have yung limit as a approaches negative infinity ng x cubed over 3 evaluated from a to 0. And then, plus the limit as b approaches positive infinity ng x cubed over 3, now evaluated from 0 to b. So, you have, first, the limit as a approaches negative infinity ng 0 minus a cubed over 3. And then, plus the limit as b approaches positive infinity ng b cubed over 3 minus 0. So, dun sa first term, saan pupunta yan? Pupunta yan sa, yung a cubed pupuntang negative infinity kasi a goes to negative infinity pero times negative 1. So, this whole thing goes to positive infinity. And then, yung second term, b cubed, as b approaches positive infinity, the whole thing will go to positive infinity. So, you have something na pupunta ng positive infinity and something na pupunta ng positive infinity. So, you have finally equal tong sum na to sa positive infinity. So, therefore, the integral from negative infinity to positive infinity ng x squared dx is divergent because the limit does not exist.
If the limit never approaches anything, the limit does not exist. The limit does not exist!
So now we move on to the second type of improper integrals. Kapag yung kaninang second condition, yung mismo integrand, yung hindi continuous dun sa limits of integration, yung hindi nasusunod. If the integrand approaches infinity at one or both of the limits of integration, the existence of the improper integral is determined from the following. First, if f is continuous at all x in the half-open interval a to b, so open sa a, close sa b, and if yung limit as x approaches a from the right ng f of x is either positive or negative infinity, then yung integral ng f from a to b will be equal to the limit as t approaches a from the right ng integral of f from t to b. So, ang papalitan nyo dyan yung a. Kasi dun siya hindi continuous. Okay? So, ganun din sa susunod. If f is continuous at all x in the half-open interval from a to b, so close sa a, open sa b, and if yung limit as x approaches b from the left ng f of x is either positive or negative infinity, then yung integral ng f from a to b will be equal to the limit as t approaches b from the left ng integral of f from a to t. So, ang papalitan nyo naman dyan ay yung b kasi dun naman siya hindi continuous. Lastly, if an infinite discontinuity occurs at the number c within the interval of integration, the existence of the improper integral is determined from the following. If f has an infinite discontinuity as c, where c is between a and b, and both yung integral from a to c ng f and yung integral from c to b ng f ay convergent, then we define na yung integral from a to b ng f of x dx ay equal sa sum nung integral from a to c ng f of x dx and nung integral from c to b f of x dx. So para siyang yung ginawa natin sa type 1 number 3 na hatiin mo muna kung saan may discontinuity, tapos kukunin mo yung improper integral nung bawat hati. And also, like before, if either integral on the right-hand side is divergent, then yung integral from a to b of f is also divergent. So for example, we have this integral. Evaluate the integral of 1 over x plus 2 squared dx from negative 2 to 1. So note na yung integrand natin, 1 over x plus 2 squared, meron siyang infinite discontinuity sa x equals negative 2. And continuous siya everywhere else naman, no? So papalitan lang natin yung limit of integration na negative 2. So we can rewrite this integral as, pili kayong variable, so halimbawa flour. So the limit as flour approaches negative 2 from the right, no? Ng integral ng 1 over x plus 2 squared dx from flour to 1. And then again, this is just substitution and then power rule. So you have the limit as flour approaches negative 2 from the right ng negative 1 over x plus 2 evaluated from flour to 1. And that just gives you the limit ng flour approaching negative 2 from the right of negative 1/3 minus quantity negative 1 over flour plus 2. And then, so we'll rewrite lang natin, that will just become negative 1/3 plus 1 over flour plus 2. And then, yung flour plus 2, this goes to, so note na this is negative 2 from the right, that is slightly greater than negative 2. So yung negative 2 from the right plus 2, that will be 0 plus. So you have 1 over 0 plus. So this whole term goes to positive infinity. And yung constant na 1/3, hindi niya man yung constant na negative 1/3, hindi niya masyadong maapektuhan. So you have, this whole thing goes to positive infinity. So since the limit does not exist, we have that the integral from negative 2 to 1 ng 1 over x plus 2 squared dx is divergent. For next example, let's evaluate this integral ng 1 over x squared dx from negative 1 to 1. So note na yung 1 over x squared na function natin, meron siyang discontinuity at 0 and that lies between negative 1 and 1. So gagawin natin yung number 3. So again, hatiin natin siya sa may 0 and then i-rewrite natin each part as a limit. So then the integral from negative 1 to 1 ng 1 over x squared dx will be equal to, so first, yung part na may negative 1 to 0, yung 0 papalitan natin ng variable say t. So this will be the limit as t approaches 0 from the left ng integral ng 1 over x squared dx from negative 1 to t. Similarly, dun sa susunod na part, yung 0 to 1, so papalitan natin yung 0 doon ng say s. So we have the limit as s approaches 0 from the right ng integral from s to 1 ng dx over x squared. So again, this is just power rule. So you have x to the minus 1 over minus 1 for both. And then yung first term will be limit as t approaches 0 from the left ng x to the minus 1 over minus 1 evaluated from negative 1 to t. And then yung second term will be the limit as s approaches 0 from the right ng x to the negative 1 over negative 1, negative 1 evaluated from s to 1. So just substituting yung respective variables, we have first yung limit as t approaches 0 from the left ng, so you have quantity negative 1 over t minus, yung susunod is negative 1 over negative 1. So that will just be negative times positive 1. And then you have the limit as s approaches 0 from the right now. So you first have negative 1 over 1 minus negative 1 over s. And then just simplifying further, we have limit as t approaches 0 from the left ng negative 1 over t minus 1 plus limit as s approaches 0 from the right ng negative 1 plus 1 over s. Okay. So again, yung mga constants ng negative 1, hayaan lang natin sila. So yung first term, negative 1 over t as t approaches 0 from the left. So you have negative 1 over 0 from the left. So that whole thing goes to positive infinity kasi 0 from the left is still negative. So magiging positive infinity siya. Again, yung second term, 1 over s goes to 0 from the right. So this term goes to positive infinity. So you have positive infinity plus something na pupunta positive infinity. So positive infinity, kahit may constant, the whole thing goes to positive infinity. So again, dahil the limit does not exist at sumasabog siya, the integral from negative 1 to 1 ng 1 over x squared dx is divergent. So for our last example, let's evaluate the integral from 0 to pi ng cosecant squared dx. So note na yung integrand natin, cosecant squared x has an infinite discontinuity both at x equals 0 and at x equals pi. So ito, hindi natin pwede siyang sabay palitan ng limit kasi pareho nga may discontinuity. So ang gagawin natin, similar sa ginawa natin for yung previous example, hahatiin natin siya somewhere inside the domain ng cosecant squared x. So, halimbawa, hati na sa gitna sa pi over 2. So, we can write that as the integral from 0 to pi over 2 ng cosecant squared dx plus the integral from pi over 2 to pi ng cosecant squared dx. And then, to each integral, we will apply number 1 and number 2 from improper integrals type 2. So, just rewriting everything. So, yung first term, papalitan nyo yung 0. So, let's choose, sige, board na tayo sa English alphabet. At ayoko na mag-drawing, so sa Greek alphabet na tayo. So, let's have the limit as, say, alpha goes to 0 from the right ng integral ng cosecant squared dx from alpha to pi over 2. And then, ganun din sa susunod. So, iba rin dapat to. So, we have limit ng, say, as beta goes to pi from the left ng integral from pi over 2 to beta ng cosecant squared dx. And then just integrating, we have that the integral of cosecant squared is negative cotangent. So you have the limit as alpha goes to 0 from the right ng negative cotangent x evaluated from alpha to pi over 2 plus the limit as beta goes to pi from the left ng negative cotangent x evaluated from pi over 2 to beta. Again, you have negative cotangent pi over 2, cotangent pi over 2 is 0, so 0, minus negative cotangent alpha. So that will just be positive cotangent alpha. And then plus you have the limit as beta approaches pi from the left ng negative cotangent beta minus, again, 0. So, yung first term, cotangent alpha, where does this go as alpha goes to 0 from the right? So, recall lang natin yung graph ng cotangent as alpha approaches 0 from the right, the graph of cotangent alpha goes to positive infinity. And then, yung sa susunod, you have yung sa cotangent beta as beta goes to pi from the left, it goes to negative infinity, tapos may negative ka sa labas, so it also goes to positive infinity. So the whole thing will go to positive infinity. So therefore, we have integral from 0 to pi ng cosecant squared dx is divergent. And note natin pala na we can use any number in 0 to pi to get the same answer. So ito yung sinabi ko kanina na pwede nyong hatiin anywhere. For situations like this, piliin nyo na yung pinaka-convenient sa inyo in terms of evaluation sa later part. Okay? Before you go, for one last time, here are some exercises you can try on your own. Before I end this video, I would just like to congratulate everyone for making it to the very end of Math 100. So don't forget, mayroon pa kayong second exam. So please study well for that. But other than that, congratulations on basically finishing the course.